Welcome to my channel, dear students. So let us begin with the first question of the day, question number 43. So in the given figure, AC is the diameter of the circle with center O. So AC is the diameter and O is the center. Chord BD is perpendicular to AC. So BD is the chord, right, which is perpendicular to AC, and it is given perpendicular out here. Write down the angles PQ and R in terms of X. So we need to find the P, Q and R in terms of X. Alright. Okay, so let us begin with the sum. Okay, so it is said that arc subtends AOB, okay, at the center. So it is actually arc AB should be written here. Alright, so there has to be written AB. So this arc AB subtends angle AOB at the center, right? And in the remaining part, it subtends ADB and also ACB, right? But ADB is not given here, right? So we are not given any angle at ADB, so that's why we'll take this. Okay, so this will be equals to how much? Q. All right, so that's why it is written AOB at the center and ACB at the remaining part of the circle. So this is my ACB. All right, so that means this has to be double of this, right? So that's what is written. So AOB is 2 times ACB. Now how much is AOB? AOB is given to be X and ACB is given to be Q. So from here X is equals to 2Q, but we need to find P, right? So that's why we need to find Q. So that's why Q in terms of X will be X by 2. So this will be our value for Q. Okay, so this is my one of the answer. All right, now let us go to another one. Now it is clearly seen that ADB, this one, and ACB are angles in the same segment AB, right? So that's why again this angle and this angle, they have to be equal to each other and both of them will be equals to Q. All right, now in triangle AED, let us see where is AED. So AED is this one. All right, now we know that this is 90 degree, right? Because BD is perpendicular to AC, so that's why this is 90 degree. Okay, now if this is my 90 degree, then we have sum of the interior angles will be equals to 180 degree. All right, so this is already P and we just now evaluated this to be Q, right? So this Q plus 90 will be equals to, from here P plus Q will be equals to 90. Now we know that the value for Q is how much? X by 2. So from here P becomes 90 minus Q and Q is X by 2. So that's why the value for P will be 90 minus X by 2. Now we found the value of P in terms of X again. All right, so this is my another answer. Now at last we need to find the value of R in terms of X. All right, so let's begin. Now let us have a look at arc BC. All right, so BC subtends angle BOC with the center, that is this angle, right? And in the remaining part it subtends angle BDC. There is another one also, that is BAC. Now again this BAC is not given, so that's why I'll go for BDC. All right, so that's why it is written arc BC subtends angle BOC at the center and BDC at the remaining part of the circle. That means this angle will be double of this, right? So that's why it is written BOC, yes, BOC will be double of this one, that is 2R. All right, now let us see what is the value of BOC. Okay, so from here it is clearly seen that R will be equals to half of BOC, right? Now we know that angle AOB, this one, AOB means this one, and BOC, if I add them they'll form a linear pair, right? So that's why it is written that AOB plus BOC will be linear pair, that is 180. All right, okay, so we know the value of AOB, and how much is AOB? AOB is X, right? So BOC will be 180 minus AOB, which is 180 minus X. Now let's go back to our work, this one. All right, because we want to find R. So from here R will be equals to, instead of BOC I am writing 180 minus X. All right, so from here what is R? So half into 180 is 90 and minus X by 2 is left. So the value for R will be X, 90 minus X by 2. So pause the video to note down. Okay, so let's have a look at the next question. So question 44 says, in the given figure, AC is the diameter of the circle with center O. CD and BE are parallel. So they are given to be parallel in the diagram itself. AOB is given to be 80 degree, alright, and ACE is given to be 10 degree, alright. So this angle is given to be 10 degree. So we need to calculate the angle BEC, BCD and CED. Okay, so let's see how to begin with the sum. So arc AB subtends angle AOB at the center. So if I take this arc AB, this AB subtends angle AOB with the center, right? Okay, so we have now in the remaining part the very same arc AC subtends angle ACB, right? So we have this ACB will be the half of this one, right? So that's what will be written here, all right. So ACB is half of AOB. Okay, now what is AOB actually? AOB is 80 degree, right? So instead of this AOB I am writing 80, and this turns out to be how much? 40 degree. That means this angle ACB is how much? 40 degree, all right. Okay, now we have BOC plus AOB equals to 180 degree. Why? Because they are linear pair, all right. So AOB plus BOC will be 180 degree. Okay, so from here we know what is the value of AOB, which is 80. So that's why from here BOC turns out to be, that is this angle turns out to be how much? 100 degree. Okay, now our aim is to find BEC, right? So we need to find BEC. Okay, now if you see here, BC is the arc which subtends angle BOC at the center, and in the remaining part this arc BC subtends angle BEC, right? So this is the arc BC, and in the remaining part, that is this part, BC subtends angle BEC, right? So that's why this BOC will be double of BEC, or BEC is half of BOC. All right, so that's what is written out here. So BEC is half of BOC, and how much is BOC? BOC is 100. So from here this turns out to be 50. So that's why angle BEC will be equals to 50 degree. All right, so we don't have space here, so you may pause the video to note down this part. Okay, now let's move on to the next part. So we have EB is given to be parallel to DC, right? So EB is given to be parallel to DC. Now whenever we have this case, we'll look for a transversal. So here we see that EC acts like a transversal, and after we see the transversal, we go for the angles like corresponding angles, vertically opposite angles and alternate angles. So clearly from here, from the diagram, we see that this angle and this angle, they are alternate angles, right? So that's what is written. So DCE, so DCE and BEC, that is this angle, they are alternate, and BEC turned out to be just now 50 degree. So that's why this angle will also be 50 degree. All right, now we are asked to find BCD. So BCD can be written as this angle, that is BCA, plus this angle, that is ACE, plus this angle, right? So all these three angles, when they are added to, we will get BCD. So that's what is written out here. All right, now let us see what is BCA. So BCA, so BCA means this angle, right? So this angle turned out to be, in the earlier question we saw that this was equals to 40 degree, right? So AC is how much? It is given to be 10, right? And ECD, so ECD, just now we found that ECD will be equals to how much? 50 degree. That is, this angle will be 50 degree. So if I put the values, then my value turns out to be 100. So that's why angle BCD will be 100 degree out here. Okay, now let's move on to the last part, that is CED. So let us search where is CED. So CED lies out here. All right, so let's begin. Okay, now in cyclic quadrilateral CDEB, so we see that C, D, E and B, all of them lie in the circumference. So that's why CDEB is a cyclic quadrilateral. Now in this cyclic quadrilateral, I can say BED plus BCD. So BED means this angle, this full angle, plus BCD, that is this full angle, will be equals to how much? Sum of these two will be 180 degree because they are opposite angles of a cyclic quadrilateral. All right. Now this BED can be written as this BED. This whole angle can be written as this angle plus this angle, that is BEC. That is, this angle is BEC and this angle is CED, right? So instead of BED, it is written BEC plus CED. All right. So these two represents this angle itself plus BCD. Now let us put the values of the known angles. So do we know BEC? That is this one. Yes, we know that. Do we know CED? No, we don't know. That's what we are supposed to find, right? Okay, now at last is BCD. Now we know how much is BCD also, right? So let us put the values. So BEC was 50 degree, right? If you have a look at the solution, it is given that BEC is given to 50 degree, CED we need to find it, BCD is 100. So from here CED turns out to be 30 degree. All right. So pause the video to note down. Okay, let's have a look at question number 45. So this question says, in the given figure, AE is the diameter of the circle. Write down the numerical value of angle ABC. So ABC, that is this angle, plus CD, that is this angle. So we need to find the sum of this angle and this angle. All right. Now before I begin with the sum, let us do some necessary construction. That is, I'll make these constructions out here. All right. That means I'll join all these, okay, and I'll name the different angles being formed. So this is my A, B, C, D, right? And this is 1, 2, 3, 4, 5, 6, 7 and 8. All right. So these are different numberings that I have given to the different angles here. Okay. So as I said, join OA, OB, OC and OD. Okay. Now let us have a look at this triangle. Okay. So in this triangle, we see that this is OA and this is OB. So both are radii, right? So that's why they will be equal. Okay. Now if these two are equal, that means this is what kind of triangle? This is isosceles triangle. Now in isosceles triangle, the base angles has to be equal, right? So that's why angle 1 and angle 2 will be equal to each other. All right. Now similarly, BOC, in BOC also this, that is OB and OC are radii. So again, in the same way, angle 3 and angle 4 will be equal. Okay. So similarly, we can prove all these things. All right. Okay. Now let us again go back to our triangle AOB. Okay. So we have sum of the interior angles will be 180 degree, right? Okay. So similarly, in another triangle also, sum of the interior angles will be given this way. All right. So this is for the second triangle. This one, this one is for third, and this one is for last triangle. All right. Now let me add all of these. Okay. So adding, we get, so in the left hand side we get, see here carefully, very carefully. So this is angle 1 plus angle 2 plus angle 3 plus angle A. So this is for the first one. For the second, it is angle 3, angle 4 and angle B. For the third one, it is angle 5, angle 6 and angle C. And the last one is angle 7, angle 8 and angle D. So angle 7, angle 8 and angle D. So this is the left hand side. Okay. So in the right hand side, we have got 4 180. So that's why it is written 4 into 180. All right. So let us evaluate. Now this angle 1 will be equals to angle 2 because it is clearly written out here, right? So instead of angle 1, it is written angle 2. Similarly, instead of angle 4, it is written angle 3. All right. So angle 5 is written as angle 6. All right. Angle 8 is written as angle 7. Okay. So others are written as it is. Hope this thing is clear to you. Okay. Now how many angle 2 are there? There are 2 angle 2, right? 2 angle 3. Similarly, 2 angle 6 and 2 angle 7. All right. So that's why it is written 2 angle 2, 2 angle 3, 2 angle 6 and 2 angle 7, and the rest are written as it is. All right. So we don't have space. Let's go back here. Okay. So from here, what is common? We clearly see that 2 is common, right? So if 2 is kept common, then we have angle 2 plus angle 3 written. All right. So from here, again we see that 2 is common, so from here angle 6 and from here angle 7 will be left. Alright, now a plus b plus c plus d, that is this plus this plus this plus this, so all this gives me a straight line, right? So what is the value of straight angle? It is 180 degrees, so that's why it is written 180 degree out here. Alright, now let us see what is angle 2 plus angle 3. So angle 2 plus angle 3 is this angle, right? Yes or no? So this angle is what angle? This is ABC. Alright, so instead of angle 2 plus angle 3, I have written ABC. Alright, so angle 6 plus angle 7 is CDE, right? So instead of this, I have written CDE. Alright, this 180 is kept out there, so it becomes 720 minus 180. And what is 720 minus 180? It is 540. Alright, so again here 2 is common, and if I send this 2 to the denominator, we will get angle ABC plus CDE will be equals to 270. That is 570. So 540 divided by 2 will be 270. Okay, so with this we have finished this problem. So pause the video to note down. Okay, let's have a look at next question. So question says, in the given figure, AOC is the diameter, AOC is parallel to ED, and CB is given to 64 degree. We need to calculate angle DEC. Alright, so everything is being said in the diagram itself. Alright, so let's directly begin with the sum. Okay, so now let me do some construction. Let me join AB. Okay, so join AB is written here. Alright, now AOC is the diameter, right? Isn't it? So if AOC is the diameter, then angle ABC will definitely be 90 degree. Why? Because this is angle in a semicircle. Alright, so this full angle is going to be 90 degree out here. Alright, so ABC. Okay, so ABC can be written as, now see here carefully, so ABC is 90 degree, right? So that's why ABE, that is this one plus, because this ABC can be written as this angle plus this angle, right? So I have written, instead of ABC, ABE, this angle plus CBE. Alright, so this angle plus this angle will be equals to angle ABC. So that's what is written out here. Alright, and what is CBE? CB is already known, which is given to be 64 degree, right? So from here ABE turns out to be 26 degree. That is, this angle turns out to be 26 degree. Alright, now AC is parallel to ED, right? AC is parallel to ED. So that's why this EC acts like your transversal. So let me see that these two are alternate angles, right? So that's what is written here. So DEC will be equals to ACE because they are alternate angles, right? Now it is given that ACE will be equals to ABE. Why? Because they are angles in the same segment. That is, if I draw this line AE, then in this segment, okay, so it is making angle ABE and ACE, right? So that means this angle and this angle, they will be equal to each other, and we already know that this is 26, so that's why this will also be 26, right? Now this angle and this angle are also equal because they are alternate angles, so that's why this CED or DEC will also be my 26 degree. Alright, so that's why it is written DEC will be equals to ABE, which will be equals to 26 degree. Alright, so pause the video to note down. Okay, let's have a look at the next question. So using the given figure, we need to find BAD. That is, BAD means this angle, alright, and DQB. So DQB means this angle. Alright, so let us find these two angles. Now let us have a look at this one. Okay, so in this triangle, that is APD, okay, in this APD triangle, so we see that this angle and this angle are given. So can't we find this angle? Definitely we will be able to find this angle. So that's why it is written that sum of the interior angles, that is ADP. So ADP plus DPA plus PAD, it will be equals to 180 degree. So let us put the values. So we know that ADP is given to be 85, DP is given to be 40, and PAD, that is this angle, is not given, right? So from here PAD turns out to be 55 degree. Now PAD means this angle, right? So this PAD can also be written as BAD. So that's why my angle BAD will be 55 degree out here. All right, now let us see this one, how to find this one. Now in order to find this, we already know this, right? So in this triangle we should be knowing this angle as well. Okay, but we see that A, B, C and D, all of them lie in the circumference of the circle. So that's why ABCD is a cyclic quadrilateral. Okay, so in cyclic quadrilateral ABCD, this angle plus this angle will be equals to how much? 180 degree. All right, now we know that ADC is 85, right? So from here ABC, that is this angle, turns out to be 95 degree. So this angle is 95. We already know that this is 55. All right, now in triangle AQB, okay, so in triangle AQB, some of the interior angles will be 180 degree. Now what is QAB? So QAB means this angle, so this angle is equals to how much? 55. All right, ABC is already 95. QB, BQA, so BQA means this angle. So let us find how much is this angle from here. So this angle BQA turns out to be 30 degree. All right, so BQA is this angle. Now can I write this as DQB also? Yes, so this can be written as DQB as well. So from here DQB turns out to be 30 degree. All right, so pause the video to note down. Okay, now let's have a look at this question. So question says, in the given figure, AOB is the diameter, DC is parallel to AB. So all these things have been already shown here, and it is given that CAB is x degree. So we need to find in terms of x. So we need to find these angles, and my answer should come in terms of x. Okay, so let's begin with the sum. So before we begin, let me join C and B here. Right, so we have written join CB. Now in triangle AOC, so in this triangle, so we have AO and OC both are radii, so that's why they will be equal. So if they are equal, then definitely this angle and this angle has to be equal. So that's what is written out here, and both of them will be equals to x. Since this is x, this is also x. All right, now in this triangle, if I extend this AO, then this becomes my exterior angle, isn't it? So COB, okay, so this angle COB will be equals to sum of the opposite interior, that is this plus this. All right, so it is written exterior COB will be equals to angle OAC plus OCA. So both are x and x, so the sum of x plus x will be 2x. So the value for this one turns out to be 2x. All right, now let's have a look at the next triangle. This is triangle ACB. Okay, so in this triangle ACB, since this is a semicircle, so ACB will be 90 degree because it is angle in a semicircle. Okay, now if this is 90 degree, then sum of this and this will be obviously 90 degree, right? All right, so that's why I've written OAC. All right, see, this is OAC. This angle can also be written as OAC, right? OAC plus OBC will be equals to 90 degree. This plus this will be 90 degree. All right, so from there OBC will be equals to 90 minus OAC, right? Okay, so and how much is OAC? OAC is x, right? So that's why this angle is equals to how much? 90 minus x. All right, now in cyclic quadrilateral ABCD, so in this cyclic quadrilateral, if you extend this, okay, it becomes a circle, and this A, B, C and D, all of them lie in the circumference. All right, so that's why this ABCD becomes a cyclic quadrilateral. So that's why the sum of opposite angle, that is this and this, becomes 180 degree. All right, so we know the value of ABC, right? That is this angle. So this angle is equals to how much? 90 minus x. All right, so ABC is also written as, ABC can also be written as OBC, isn't it? So we have OBC is 90 minus x. So from here ADC turns out to be how much? 90 plus x, because 180 minus 90 is just 90 plus x is there. So ADC, that is this, turns out to be 90 plus x. All right, so let's move on to the next part. So next is DC is parallel to AB. So DC is parallel to AB. Now if this is given, what is the meaning of this? We have DCO. So DCO, so this acts like your transversal here. Okay, so if I take CO as transversal, then this DCO will be equals to COB, that is this angle, right? So this angle and this angle, they will be equal, and they will be equal to 2x, right? Because we already know that this is 2x. All right, so they are alternate angles here. So DCA, so let us see where is DCA. So DC, okay, so this is DCA will be equals to CAB. Again, this one and this one, they are again alternate angles, so that's why this will be also x degree. All right, so this is x, so that's why this will also be x. Okay, so in triangle ADC, so let's see where is ADC. So ADC is this triangle. Okay, so in this triangle we have sum of the interior angles equals to 180 degree, isn't it? Okay, so where is, okay, so let us see what are the things given to us. So DAC we don't know, so DCA. All right, so DCA, just now we found this to be how much? X. So instead of DC it is written x. And what is ADC? So we have already found ADC, right? So ADC was equals to 90 plus x. So 90 plus x is written here. So from here DAC, okay, so x plus x is 2x plus 90 degree plus DAC will be 180, and from here DAC turns out to be, so take all this out there, so your answer will be 90 minus 2x. So angle DAC will be 90 minus 2x. So this is also found. Now we are left with DOC, that is DOC. Okay, now in triangle OCD we have sum of the interior angles equals to 180 degree, right? Now OCD, let's see what is OCD. So OCD, see, this is also x, this is also x, so altogether this is 2x, right? So it is already written DCO will be equals to 2x. All right, so instead of DCO or OCD it is written 2x here. And next is CDO, so CDO will be equals to again 2x. All right, so we have from here DCO, okay, so 2x plus 2x will be 4x. So from here this 4x goes over there, becomes 180 degree minus 4x. So that's why my DOC will be equals to 4x out here. All right, so you may pause the video to note down.